We're going to work on graphing a spherical triangle. And so the challenge to graphing a spherical triangle is that it's not one equation that defines it. So what you would need to do is graph your 3D sphere, just like I have here. And I used a radius of 5 just so that I could see a little bit better the way things are going to intersect. I would say anywhere between 5 and 10 would be a good radius size. Anything smaller than that, and you're going to have kind of an issue being able to see the triangle as it occurs. The other piece is that a spherical triangle is not built from an equation, it's built from the intersection of 3 separate planes. So in order to graph a spherical triangle, you're going to have to graph 3 separate planes. And planes are the rectangle pieces that are going through that sphere. So you can see I have one entered. I did x plus y plus z equals 0, and that gives you this the plane that's currently cutting the sphere diagonally perfectly. So that does cut through the origin of the sphere and cuts it perfectly in half from a diagonal angle. What I chose then to do was to graph the plane x equals 0, and once I extend it to 3D, you're going to see how it divides the sphere further up. And so here you can see all the different ways that I can see different shapes that are between the 2 planes that are right here. So if I come around, and you'll see that they're basically kind of quadrilateral shapes here. They're not quite the triangle. So this plane vertically cuts my ball perfectly, or my sphere, and then when I add y equals 0, now I can see some really interesting intersections. So first of all, not every intersection of 3 planes is going to form a spherical triangle. So you're going to kind of have to hunt through your image here. So if I look at this, do you guys see how this is perfect here? I've got this kind of slice wedge, so I've got a spherical triangle here if I consider it to be cut by this bottom plane. If I am considering the entire plane, including what's at the bottom, that's not really going to work out so well. So I have to look at that piece. Now, the really nice spherical triangle is the one over here. And you'll see the 3 planes basically make a triangle right here. And here I can see that really nice spherical triangle. I am using my Mac, and that's how I'm sliding around the image of that sphere. But here you can see that really nice spherical triangle happens between this intersection. So the challenge for this week is not only to graph a spherical triangle, it's to graph it to manipulate the shape around so that you can actually find that perfect spherical triangle. That there might be 1, there might be 2, there might be 4, and then identify that. And so if I was traveling on the globe, sometimes this mouse is so hard to deal with. If I was actually traveling on the globe, it would be this point to this point, and it's on the surface of the globe, which is why it's not a straight line. It's got that curvature. And then this point to this point, and so on. So this could be applicable to travel by water in a boat, travel by train. This could also be relevant for triangulation. So when you're using your GPS on your cell phone, there are 3 satellites, and they are basically using a spherical triangle to locate where you are in between and relevant to the different satellites. So this week, this is what we're kind of working on, is not just cutting the sphere, but after we cut the sphere, how do we, look at it and then identify where that triangle is, and then we would photograph that region to show that you were able to generate one. So the challenge is to generate one using 3 equations that are not these 3 equations, to photograph it, and then to submit that in.